Welcome to the December test of the Math Open. Question number 1. Guilford County Schools has an annual budget of $661 million to serve 72,000 students. How much are taxpayers paying for each student to go to school for a week? Now let's know that there are 180 school days in a year. So how do we figure this out? The first thing we need to do is we need to figure out how much money is spent per student per year. You can do that by taking $661 million divided by 72,000 students, and you get $9,181. So Guilford County Schools spends $9,181 on each student. Then we need to figure out how many weeks are in a school year, or what proportion of the entire school year is 1 week. Well, we know there are 5 days in a week, and there are 180 days in a school year. So we can take 5 divided by 180, and you get 0.2778. So then we can just multiply and say how much of the annual budget per student goes into 1 week. That's the 9,181 you figured in the first problem, and the 0.02778 in the second part. Multiply those together, and you get $255. So that is how much Guilford County pays for each student for a week of school. So kids, when you think about going to school this week, know that your mom and dad and all the taxpayers in Guilford County are paying $255 for you to go to school. Make sure you make it worth it. Question number 2. You will be taxed on your first paycheck. You'll pay 6.2% for Social Security and 1.45% for Medicare. Plus, you're going to pay 15% in income taxes to the U.S. government and 5.75% to the North Carolina government. If your weekly paycheck is $1,000, how much do you have after taxes? So this is a tough thing in life when you get older, is you have to pay a lot in taxes. The first part of this problem we need to do is add up all the taxes. So we can add up 6.2%, 1.45, 15, and 5.75, and you get 28.4%. So that's the total amount of taxes you'll pay. So then what we can do is figure out how much of your paycheck is going to be taxed. So you take your $1,000 paycheck, multiply it by 28.4%, and you get $284. And then we just need to figure out how much you get to keep. So you take that same $1,000, you subtract the $284 that you had to pay in taxes, and you get $716 that you get to keep. Welcome to the world of adulthood and being taxed, everybody. Question number 3. Your awesomeness is determined by how hardcore you shred, which is a variable called HCS, and how naturally gnarly you are, which is a variable called NG. And your awesomeness is determined by the formula A equals 0.5 times HCS cubed plus 2 times HCS squared plus 6 times HCS times NG plus 7 times NG minus 30. If you hardcore shred at a 7 and you are naturally gnarly at a 5, how awesome are you? So this is kind of a silly equation, but this is actually something you do a lot in algebra and almost all math. So let's take this big ugly equation. And remember, don't get freaked out about it. It's actually pretty simple. We have all these variables, but we know what the variables are. So everywhere where you see an HCS, put a 7. And everywhere where you see an NG, put a 5. So you can rewrite this equation so it's A equals 0.5 times 7 raised to the third power, plus 2 times 7 raised to the second power, plus 6 times 7 times 5, because that's your naturally gnarliness, plus 7 times 5 minus 30. And then this actually becomes really easy. You just multiply everything through and get your answer. So the first thing I did, I just did the exponents. So I said A equals 0.5 times, instead of 7 to the third, I said 343, plus 2 times, instead of 7 squared, 49, and then everything else the same, just so it's a little easier to do on your calculator. And if you multiply all that stuff through, you get 485. Again, this is a very silly equation, but it illustrates the point of taking variables and putting them into an equation. And you'll notice, as big and ugly and hairy as that equation is, once you put the variables in, once you find every HCS and put a 7 in there, and once you find every NG and put a 5, it's really not that bad. Good job, everyone. Question number 4. Here's a probability question. You have 5 quarters, 5 dimes, 3 nickels, and 2 pennies in your pocket. If you randomly picked 3 coins, what is the probability you would have at least 70 cents? So let's draw out all your coins. You have your 5 quarters, your 5 dimes, your 3 nickels, and your 2 pennies. Now, the first thing you have to realize is that if you pick 3 coins, if you want to get at least 70 cents, you have to have a quarter every time. There's no other way you could have 3 coins to get up to 70 cents. Even if you imagine 2 quarters and a dime, that would only get you to 60 cents. So that's really one of the key parts of this question, is realizing in order to do this, you have to get a quarter every time. So really the question is just asking, what's the probability of picking 3 quarters? So with your first coin, we know that there are 5 quarters and 15 total coins. So the probability of your first coin being a quarter is 5 out of 15. For your second coin, it's a little different. It's not 5 out of 15, it's 4 out of 14 because we already took a quarter out. We've done problems like this before, so hopefully that seemed a little familiar. And then your third coin should be pretty easy if you follow that pattern. Instead of 4 out of 14, it's 3 out of 13 because now you've picked 2 of the quarters. And then just like we've done before, we know that the probability of your first coin being a quarter is 5 out of 15. Your second coin being a quarter is 4 out of 14, and your third coin being a quarter is 3 out of 13. And we want to know is what is the probability of all of these 3 things happening together. And we should recall that you can just multiply all that out. 5 over 15 times 4 over 14 times 3 over 13. And if you multiply all that out, you get 60 over 2,730. And if you can make that into a percentage, which is 2.2%. This is probably one of the harder problems we've done. So if you got this, good job, everybody. But remember, every single one of you is smart enough to do this. It's just a matter of understanding what you want to do with the probability, which coin you want to pick, and then multiplying the probabilities out. Question number 5. You knew there would be a compound interest problem. So Pete has $900 to invest for 20 years. How much more would he make if he could invest the money at 9% instead of 7%? Well, so we always use this equation. Hopefully you guys are starting to get used to it. You take what you start with times 1 plus your interest rate raised to the number of years, and that equals what you end with. So S times 1 plus R raised to the Y equals E. Okay, so we know we're going to start with $900, have an interest rate of 7% in 20 years. Let's put that all in. 900 times 1.07 raised to the 20th, and that equals $3,483. Now we want to compare that to if he could invest it the same amount of money, the same number of years, but the interest rate is 9% instead of 7%. We have a very similar looking equation, except the 0.07 is changed to 0.09. So we have 900 times 1.09 raised to the 20th, and that gives us 5,044. So then we can just subtract those. That's pretty easy. 5,044 minus 3,483, and we get our answer of 1,561. So just by increasing the interest rate 2%, Pete can get an extra $1,561. And that is a really powerful part of compound interest. Question number 6. This is actually a question that Ms. Johnson, Dr. Johnson, asked me, and we thought it was a really great question to ask the geniuses, which is you guys. So there are 30 students taking a really hard math test. What is the probability that none of them are born in December? So we have 30 students, and we don't know their birthdays, but what's the probability that not a single one of them is born in December? Well, let's break this down into something a little easier. What if we just had one student? What's the probability that one student is not born in December? And we could figure that out. There are 12 months in a year. So the probability of the student not being born in December is 11/12. Now let's make it a little bit harder. What if we had 2 students? We have a second student, same probability, 11/12. So what's the probability that both of them are not born in December? Just like question number 4 with the coins, we take these 2 probabilities and we multiply them together. 11/12 times 11/12 gives you 84%. Now, hopefully, a light bulb went off in your head and you said 11 over 12 times 11 over 12 is the same as 11 over 12 squared. And that gave us the probability for 2 students. Now, we want to do it for 30 students. And hopefully, again, the light bulb in your brain is going off and you say, well, what if you do 11 over 12 times itself 30 times? Because when we just had 1 student, the right answer was 11 over 12 times itself 1 time. When we had 2 students, the right answer was 11 over 12 times itself 2 times. If we have 30 students, the right answer is 11 over 12 times itself 30 times. And we can do that and we get 7.35%. And that's your answer. Congratulations, everybody. As I say every single time, these are hard tests. So just the fact that you're sitting down for these shows you're an unbelievably good math student. If you get 1 or 2 of them right, that is just incredible, and I'm very proud of you. Obviously, we didn't take the test on Martin Luther King Day. I hope everybody celebrated that holiday. And then we won't take the test this coming Monday, which is a teacher work day. So we will take our next test on February 4th. I hope to see all of you then. Great job.